In this video, we are going to see about the union and bit fields in C programming. We can say union is a special type of a data type that is available in C. Actually, it is a concept that was borrowed from structures, and it follows the same syntax as the structures. So union, where the structure will store the different data types like int, float, and character. Union also used to store the different data types like character, int, float, unsigned integer, signed integer, double, long. All those different data types we can store within a specified memory location. But in structures, all those data types will be allocated with different memory location. In union, all the data types that was specified inside the union will have the same memory location. In structures, we are having union. In structures, we are having the structure tag that is optional, and here is also you're having the union tag. It is also optional here. Like we are defining the members inside the structure, so here also inside the union we are defining the members of the union like int and float, and after that we have to use a variable, and that variable will be assessed by using the member assess operator dot, like we have used in structures. So the structures and unions are the same concept. The only thing the union differs from the structure is that it has the same memory location for all the data types that were specified here. But in structure, different data types will be allocated at different memory location, but in union all the data types will have the same memory location. So in union we can say union may contain different members of different data types, and it can handle only one member at a time. So because all those members were stored in the same memory location, we can assess the member by using the member assess so we can assess the member by using the member assessing operator, and that operator will be assessing that particular variable, and using that variable will be handled at only one member at a time, not like structures. So this is the structure declared for a union. This is same like structures. So declaring for declaring a union, you must have the union keyword followed by union tag name. That tag name is optional. So we are defining the structures inside that members. That member may be of different data type as we discussed earlier. So different data type members, member 1, member 2, member 3. After defining all those members, you can have the variables at the last. That variable where we can have n number of variables. So after completing that variable declaration, we have semicolon at the last. So this is the declaration of a union. So in order to have a union, we must have a union keyword, and tag name is optional. Inside the curly braces, members of the union, and outside the curly braces we have the variables of the union. We can define more than one variable outside the union structures followed by a semicolon. So this is same like structures. So union data int I, float f, character str20, a string array of 20, and it is having the data variable. So here the variable data, it can have the members like int I, float f, and character string. All those members will be stored in the same memory location. So in order to get the memory, the particular member, we have to access only one member at a time. So how the memory in a union be declared is the memory of the union will have the what is the largest memory that was carried away by that particular member is equal to the memory of the union. Here supposing we are taking int I, so int I for storing an integer it requires 4 bytes, float requires supposing it requires 8 bytes, for character it requires for storing a single character it requires 1 byte. So here it is, I have assigned 20 characters, so 1 into 20 20. So the major or the larger memory needed by that member of the union, here it is the character string, so it needs 20 bytes. So the memory allocated for the whole structure of union will have the memory of 20 bytes. So this was the main disadvantage of the union. In some cases it is allocating memory for only a particular member, largest member present in the union. Sometimes it is an advantage also, because it is it is having the storage capacity for the other definitions also. So while in this case, if you need to access all those members at the same time, it will give an erroneous report, since the union will have the memory that to be accessed by only one member at a time. So the largest member here present is this character. Since the character stores 1 byte, here it is I have allotted 20 memory characters, so 20 bytes will be allotted for the whole union. That 20 bytes will be used by integer, that 20 bytes will be used by float, and that 20 bytes will be used by the character. Okay, let's see this program. So this program will say is union and deeply. As usual, stdio.h header file and string.h header file. I am declaring a union structure, union with a keyword of data. It is the tag name, int I, it is integer, float, and string of 20, it is character string of 20, and int main. So within that I am declaring another variable of the data. So this is another way of representing a data, declaring data. So far we have declared the variables outside the structure of the union. So you can also declare a variable inside the main function under the tag name of capital data with the keyword of union. So keyword followed by the tag name capital data, and what is that variable name you are going to define it as the small data, small d data. So small d data, it is a variable that was present in the union structure with the tag name of capital data. So in order to access that data with the member, we need the member operator. So the member operator, or when we are assessing the members of the union, that should be the variable followed by the member operator dot followed by a member. So variable dot member, in short forms you recollect like a variable dot member. So the variable here, it is the small data dot the member operator, and I represent to the integer. So integer I am going to declare here it is 10. So float data dot f, that is variable data dot member operator, f it is the float member, so which is equal to 2.5. so I'm going to using the string copy function. So where the EC has to be stored, it is data dot string. I have to store the data dot string. Okay, so here I have used string copy. It is a string manipulation function here, so that I have used the string header file at the before. So hash string. So the if you are using any peculiar functions here, you must add the corresponding header at the front. So hash include string copy data dot structure ECE. So printf data dot I is percentage d data dot I, that is a member dot variable, sorry, variable dot member data dot I, and for printing the float data dot f, and here data dot f, and data dot string percentage yes. So string we are going to copy, so that for that percentage yes, data dot string and return of 0. Since I have declared my main as an integer function, so I have put at 0. So in the second part of the slide, you must see that all those things are same. So having the header file same, having the union structure is the same, and inside the main function same union struct keyword and data as tag name and small data as variable, yes, of course the same lines, and after that it is variable dot member data dot I is equal to 100. Okay, after data dot I have asked the system to print the data dot I. So in the first part of the slide, it is I have defined all those things, declared all those things, initialized all those things, and after that I am going to print the datas. So here once as soon as I have initialized data dot I is equal to 100, I ask the system to print. So here data dot f is equal to 2.5, I ask the system to print. Next, copying ECE to data dot string variable, so I have asked the system to print. So what is the difference that is going to happen? So let's see in the next slides. The first slide, if you see, as I have stated before, union members will have the same memory location, and you can access only one member at a time. So if I have declared all those declared at all those variables and have initialized all those variables, after that only I am printing all those variables. So this produces an error in data dot I printing. So since the last one I have asked the system to print, it is data dot str. So whatever the number I have last declared or initialized, that one will be copied in that particular memory location. The previous ones I have initialized will be erased off. So this is the disadvantage of the union, where I can access the member at particular memory location at least by only one member at a time. So I have defined I 100, f is equal to 2.5, and at the last I have in the same particular location I have initialized a string ECE there. So see, in same memory location I am doing all those things, 100, 2.5 and ECE. What is the value I have I have initialized at the loss, or the updated value will be stored in that particular memory location, so that in the output it has produced an anonymous report, data dot I is equal to some garbage value, data dot f is equal to some garbage value. The last one, which was the updated one, ECE, was stored here. So this is in the next slide. The second part of the program, that is data dot I is equal to 0. So once I have initialized data dot I is equal to 0, I have asked it to print, so it will print the value. After 100, what I ask the computer to do is data dot f is equal to 2.5, yes, and I print that one, so it is 2.5, it will be printing. So after that, ECE will be stored in the member of str, so it will be ECE will be in the output. So this says these two programs will give the difference between the unions. Okay, next it is the bit fields. So bit fields, what to say, so if supposing that we are having an integer that to store an integer we need some 16 bits. Okay, so what happens when that particular integer is not requiring that much space? So if I have allotted 16 bits of data to store 16 bits of memory location to store a particular data, but I have used only 8 bits of data, so the remaining 8 bits will be unused. So this is this is not an efficient way of utilizing that memory space. So in that particular scenario, we can use the bit fields, that offers a better way to utilize the memory space. Okay, so this bit fields variables we can declare within the structure, and how we can have a bit field. So this is the declaration of the bit field. Yes, I have a struct with the type name, what is the data type, int or float or whatever it is, what is that member name, yes, yeah, member name, and within the colon I have used the width of the data. So the simple program on the second half of the slide will show the bit declaration form. So as usual, I have stated it as an studio.stdio.h, and without that width I have declared. So struct unsigned if it is some integer unsigned type, I have this is set1 with a variable. Okay, set1 with a variable. So next time I have defined with bit fields. So next unsigned f with colons of 1. So this time I have stated that I have used only 1 bits for that. So okay, so within the main program printf, the memory size occupied by the set1 percentage d, the percentage d value will be called off from the size of set1. So size of set1 will return the value of size of the int f. Okay, so next printf memory size occupied by the set2, where the set2 I have defined unsigned int f colon of 1. So I have stated that a one part of the one part of the integers size will be used. So while running that program, you will be getting the output of memory size occupied by the set is 4 and memory size occupied by the set 2 it is 2. So this is how we can reduce a memory space allotted by the system by using the bit field declaration. Thank you.